This week we look at two types of motion in two dimensions, circular motion and projectiles. Projectiles first, and we'll start with a very old question. Which falls more quickly, a heavy object or a light one? Here, an apple and a ring fall at approximately the same rate. For a spanner and a hammer, we can't see a difference. But for a hammer and a feather, a big difference. The difference is due to the force required to push air out of the way. See how this paper bends when I move it through the air, and how slowly it falls. What if we drop the hammer and feather on the moon, where there's no air? Well, a couple of NASA astronauts did that, and without air resistance, the hammer and the feather fall at the same rate.
Oh, wow, watch this. Joe, you have a good picture there. I've got
Beautiful picture, Dave.
Well, in my left hand, I have a feather. In my right hand, a hammer. And I guess one of the reasons we got here today was because of a gentleman named Galileo a long time ago who made a rather significant discovery about falling objects in gravity fields. And we thought that where would be a better place to confirm his findings than on the moon. And so we thought we'd try it here for you. The feather happens to be appropriately a falcon feather for our falcon. And I'll drop the two of them here, and hopefully they'll hit the ground at the same time. How about that? Which proves that Mr. Galileo was correct in his findings.
In case you're interested, we provide a resource explaining and quantifying air resistance. But here we'll concentrate on objects that are heavy enough, small enough, and moving slowly enough that we can neglect air resistance, as we could for the apple, the ring, and the hammer in our examples. When gravity is the only non-negligible force acting, we say an object is in free fall. I drop a ball from height h. I drop a second ball from twice as high, 2h. Does the second ball take twice as long to fall? That sounds like a question for you.